Hi, welcome back to this channel. So in the previous session we discussed the compressibility factor, how the gas undergo compression, and the compressibility factor equation in the mathematical form Z is equal to PV by nRT and all that. The variable things we observed in the value of the Z. What is the value of Z for ideal gas? It is 1, and for different gases, the real gases, the Z may be greater than 1 or less than 1. If it is lesser than 1, easily compressible, a small amount of pressure is enough. If the value of Z is more than 1, like hydrogen, helium, and they does not easily undergo compression. So these are all part we discussed in the previous video. Okay. Next we move on to the very important concept, van der Waals equation for real gases. Okay. What it says, what ideal gas equation is PV is equal to nRT. Okay, this one is known as ideal gas equation. Then what about for real gas? Which equation is holds for real gas? For that purpose, van der Waals studied the behavior of real gases. By considering the behavior, he gave the equation van der Waals equation for real gas. Van der Waals equation for real gas. There is a method of derivation for the real gas equation. I don't go in depth of that part because it is not included in your syllabus. In your syllabus, directly equation was given but I just give the hint how this part is introduced or how this equation is derived and all that. What are the things we needed? In case of an ideal gas equation, PV is equal to nRT. In case of real gas, PV is not equal to nRT. We can't change the right hand side of the equation in the both the case, correct? In case of a real gas, nRT remains constant. In ideal gas, nRT remains constant for a given temperature. Then what are the things changed? Only P and V are changes in the real gas. What is the reason of change in the pressure? What is the reason of change in the volume? And how much pressure we should correct it and how much volume we should correct it? After giving the correction for that two factor, pressure and volume, then the equation may be, the PV may be equal to nRT. Then what are the important factor we should correct it in this two part on pressure and volume? So that part was explained by van der Waals, that is known as van der Waals equation of real gas. Ideal gas PV is equal to nRT anta helutte, but in real gas PV is not equal to nRT alva. nRT helodu yadrullu changes agodilla, for a given temperature nRT remains same. Hagidre only pressure matte volume changes. ಆ ಪ್ರೆಷರ್ ಮತ್ತು ವಾಲ್ಯೂಮ್ ಚೇಂಜಸ್ ಆದರೆ ಎಷ್ಟು ಚೇಂಜ್ ಆಗ್ತದೆ ಅದಕ್ಕೆ ಕರೆಕ್ಷನ್ ನಾವು ಕೊಟ್ಟಿದ್ರೆ ಏನಾಗ್ಬೋದು, ಪಿ ವಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎನ್ ಆರ್ ಟಿ ಅಂತ ಮಾಡ್ಬೋದು. ಪ್ರೆಷರಿಗೆ ಏನೋ ಒಂದು ಸ್ವಲ್ಪ ವಾಲ್ಯೂಮಿಗೆ ವಾಲ್ಯೂಮ್ ಕರೆಕ್ಷನ್ ಕೊಟ್ಟರೆ ಪಿ ವಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎನ್ ಆರ್ ಟಿ ಆಗ್ತದೆ. ಸೊ ಯಾವ ಕರೆಕ್ಷನ್ ಕೊಡಬೇಕು, ಆ ಕರೆಕ್ಷನನ್ನು ಕೊಡಲಿಕ್ಕೆ ಅಂತ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿ ಕರೆಕ್ಷನ್ನ ಕೊಟ್ಟಿರೋ ಇಕ್ವೇಷನ್ ಏನಿದೆ ಅದನ್ನು ನಾವು van der Waals equation for real gas ಅಂತ ಕರೀತೇವೆ. ಓಕೆ, that is van der Waals equation. First is correction for pressure. Okay, ಹೇಗೆ ಕರೆಕ್ಷನ್ ಅನ್ನು ಕೊಡೋದು ಪ್ರೆಷರ್ಗೆ? if we consider a real gas system. Okay, this is the real gas system. These are the gaseous real gas molecule. These are the real gas molecule. In these cases, pressure is applied. Okay. Suppose ನಾವು ರಿಯಲ್ ಗ್ಯಾಸ್ಗೆ ಪ್ರೆಷರ್ ಅನ್ನು ಅಪ್ಲೈ ಮಾಡ್ತೇವೆ. ಪ್ರೆಷರ್ ಅಂದ್ರೆ ಏನು? ಒತ್ತಡ. ಓಕೆ, ಒತ್ತಡವನ್ನು ಗ್ಯಾಸ್ಗೆ ಹಾಕ್ತೇವೆ. ಇಲ್ಲಿ ವಾಲ್ಯೂಮ್ ಫಿಕ್ಸ್ಡ್ ಇದೆ. ಓಕೆ, ಇನಿಷಿಯಲಿ ವಾಲ್ಯೂಮ್ ಒಂದು ಫಿಕ್ಸ್ಡ್ ವಾಲ್ಯೂಮ್ ಇದೆ, ಟೆಂಪರೇಚರ್ ಫಿಕ್ಸ್ ಇದೆ, ಅಮೌಂಟ್ ಆಫ್ ಗ್ಯಾಸ್ ಒಳಗಡೆ ಇರುವ ಅಮೌಂಟ್ ಆಫ್ ಗ್ಯಾಸ್ ಕೂಡ ಒಂದು ಫಿಕ್ಸ್ ವ್ಯಾಲ್ಯೂ ಇದೆ. ಚೇಂಜಸ್ ಏನಾಗುತ್ತೆ, ಪ್ರೆಷರ್ ಆಫ್ಟರ್ ಅಪ್ಲೈಯಿಂಗ್ ದ ಪ್ರೆಷರ್ ವಾಲ್ಯೂಮ್ ಗೆಟ್ ಚೇಂಜ್ಡ್, ವಾಲ್ಯೂಮ್ ಚೇಂಜಸ್ ಆಗ್ತದೆ. ಸೊ ಹೌ ವಾಲ್ಯೂಮ್ ಚೇಂಜಸ್ ಆ್ಯಂಡ್ ಹೌ ಮಚ್ ಪ್ರೆಷರ್ ವಿ ಅಪ್ಲೈಡ್ ಆ್ಯಂಡ್ ಆಲ್ ದ್ಯಾಟ್. ಇನ್ ಕೇಸ್ ಆಫ್ ಎ ರಿಯಲ್ ಗ್ಯಾಸ್ ಕರೆಕ್ಟಾಗಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ ಏನು ಹೇಳುತ್ತೆ, ರಿಯಲ್ ಗ್ಯಾಸ್ ಸಿಸ್ಟಮಲ್ಲಿ ದೇರ್ ಈಸ್ ಎ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಬಿಟ್ವೀನ್ ದ ಗ್ಯಾಸಸ್ ಮೊಲಿಕ್ಯೂಲ್. So in ideal gas there is no force, but in case of real gas there is a force. ಯಾವಾಗ ಕೊಟ್ಟಿವಿ ಇದನ್ನು ಲಾಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ. ಟೂ assumption or postulates of kinetic theories are completely not completely holds good for a real gas system. What are these two assumptions? One is there is no force of attraction. Second one is volume of a gas molecule is comparable, only non-comparable ಆಗಿತ್ತು, or negligible to the total volume of the gas ಅಂತ ಐಡಿಯಲ್ ಗ್ಯಾಸಲ್ಲಿ ಹೇಳಿದ್ದೇವೆ. ಬಟ್ ರಿಯಲ್ ಗ್ಯಾಸಲ್ಲಿ ವಾಲ್ಯೂಮ್ ಇಸ್ ಕಂಪ್ಯಾರಬಲ್. ಓಕೆ, ನೋಡಿ ಪ್ರೆಷರ್ ಅಪ್ಲೈ ಮಾಡಿದ್ದೇವೆ. ಓಕೆ, ವೆನ್ ವಿ ಅಪ್ಲೈ ದ ಪ್ರೆಷರ್ ಗ್ಯಾಸಸ್ ಮೊಲಿಕ್ಯೂಲ್ ಆರ್ ವಾಲ್ಯೂಮ್ ಆಫ್ ದ ಸಿಸ್ಟಮ್ ಡಿಕ್ರೀಸಸ್. ನಾವೇನು ಮಾಡಿದ್ದೇವೆ, ಪ್ರೆಷರ್ ಅಪ್ಲೈ ಇನ್ಕ್ರೀಸಸ್, ವಾಲ್ಯೂಮ್ ಡಿಕ್ರೀಸಸ್, ವಾಲ್ಯೂಮ್ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ. ಅಪ್ಲೈ ಮಾಡ್ತೇವೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಲ್ಲಿ ಅಪ್ಲೈ ಮಾಡ್ತಿರೋ ಪ್ರೆಷರ್ 2 ಯೂನಿಟ್ಸ್, 2 ಯೂನಿಟ್ಸ್ಗೆ ಎಷ್ಟು ವಾಲ್ಯೂಮ್ ಡಿಕ್ರೀಸ್ ಆಯಿತು, 2 ಯೂನಿಟ್ಸ್ ಡಿಕ್ರೀಸ್ ಆಯಿತು. ಏನಂತ ನಾನು ಕನ್ಸಿಡರ್ ಮಾಡಿಲ್ಲ, ಯೂನಿಟ್ಸ್. ಓಕೆ, ಎನಿ ಯೂನಿಟ್ಸ್, 2 ಯೂನಿಟ್ಸ್, 2 ಅಟ್ಮಾಸ್ಫಿಯರ್ ಪ್ರೆಷರ್ ಹಾಕಿದ್ದೇವೆ, 2 ಅಟ್ಮಾಸ್ಫಿಯರ್ ಪ್ರೆಷರ್ ಹಾಕಿದ್ದೇವೆ, ಬಾರ್ ಪ್ರೆಷರ್ ಹಾಕಿದ್ದೇವೆ. ಸೊ ಇಲ್ಲಿ 2 ಮಿಲಿಮೀಟರ್ ಕ್ಯೂಬ್ ಅಷ್ಟು ಡಿಕ್ರೀಸ್ ಆಗಿದೆ ಅಂತ ಅನ್ಕೊಳ್ಳಿ, ಜಸ್ಟ್ ಕನ್ಸಿಡರ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಕೇಸಸ್, when this molecule volume decreases, molecules of the gases come near to each other, correct? Molecule comes near to each other. When two molecule or molecules of a gas come near to each other, then there is a force of attraction. There is a force of attraction. The force of attraction gets started now. More force of attraction we observe. What happened? Due to the decrease in the volume, due to decrease in the volume, molecule come near to each other and force of attraction increases. Due to that, molecule combine each other, and whatever the amount of pressure you applied, according to theory, okay, again 2 unit plus 2 units of pressure is applied. Once you apply the pressure, it comes in this part. Again you apply the pressure of 2 units. According to the initial equation, 2 units of pressure, 2 units of volume decreases. But according to that, 2 units of volume should be decreases according to theory. But practically what happened, because of force of attraction, it decreases by 3 units. ಏನಾಗಿದೆ ನೋಡಿ, ಕರೆಕ್ಟಾಗಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳಿ. ವಾಲ್ಯೂಮ್ ಆಫ್ ಗ್ಯಾಸ್ ಇದೆ, ಇಷ್ಟಿದೆ. ಓಕೆ, ಪ್ರೆಷರ್ ಅಪ್ಲೈ ಮಾಡಿದರೆ ಇಷ್ಟಾಯಿತು, ಮತ್ತು ಅದಷ್ಟೇ ಸೇಮ್ ಪ್ರೆಷರ್ ಹಾಕಿದರೆ ಇಷ್ಟು ಆಗಬೇಕಿತ್ತು, ಸೇಮ್ ಯೂನಿಟ್ ವಾಲ್ಯೂಮ್ ಡಿಕ್ರೀಸ್ ಆಗಬೇಕಿತ್ತು. ಬಟ್ ಏನಾಗಿದೆ, ಮೊಲೆಕ್ಯೂಲ್ ಹತ್ತಿರ ಬಂದಿರೋದ್ರಿಂದ, ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಆಗಿರೋದ್ರಿಂದ, ನಾವು ಅಪ್ಲೈಡ್ ಮಾಡಿರೋ ಪ್ರೆಷರ್, ಅಪ್ಲೈಡ್ ಪ್ರೆಷರ್ ಪ್ಲಸ್ ಅಟ್ರಾಕ್ಷನ್, attraction of what? Attraction of gaseous molecule. These two combine. Because of that, 2 unit volume decreases. According to theory, 2 unit volume should be decreases, but in practically 3 unit decreases. Okay, in real gas system, because of that, these two factors should be corrected. Otherwise, PV is never equal to NRT. So ಅದಕ್ಕೆ correction factor ಅನ್ನು ಕೊಡಬೇಕು. Understand the concept? Okay. In case of a real gas system, there is a force of attraction, dispersion force or London force. Because of that, theoretical pressure and variation of theoretical pressure and volume is different. Practically, variation of pressure and volume is different. The practically, we observe the difference in the pressure and volume. Because of that, we should subtract the amount of volume. ಏನು ಮಾಡಬೇಕು, ಇಲ್ಲಿ ವಾಲ್ಯೂಮ್ ಹೆಚ್ಚು ಡಿಕ್ರೀಸ್ ಆಗಿದೆ, 2 ಆಗಬೇಕಾಗಿರೋ 3 ಆಗಿದೆ. ಅದಕ್ಕೆ ವಾಲ್ಯೂಮ್ ಅಲ್ಲಿ ನಾವು ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಬೇಕು, ಪ್ರೆಷರ್ ಅಲ್ಲಿ ಎಡಿಷನ್ ಮಾಡಬೇಕು ಅಲ್ವಾ. ಪ್ರೆಷರ್ ಪಾರ್ಟ್ಗೆ ಎಡಿಷನ್, ವಾಲ್ಯೂಮ್ ಪಾರ್ಟ್ಗೆ ಸಬ್ಸ್ಟ್ರಾಕ್ಷನ್ ಮಾಡಬೇಕು. ದಟ್ ಪಾರ್ಟ್ is derived by van der Waal. That part after the correction factor is P ideal I. It is R real. P ideal. This PR is equal to PI only when we add some amount of pressure. That some amount of pressure is nothing but n square A divided by V square. Okay, AN square by V square. And VI ವಾಲ್ಯೂಮ್ ಆಫ್ ಐಡಿಯಲ್ ಗ್ಯಾಸ್ ಇದಿಷ್ಟೇ ಆಗಬೇಕು. ಯಾವುದು ವಿ ಆರ್ ಅಂತ ಹೇಳಿದ್ರೆ ಏನು ಮಾಡಬೇಕು, ವಿ ಶುಡ್ ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಸಮಥಿಂಗ್. ದಟ್ ಸಮಥಿಂಗ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಎನ್ ವಿ. ಓಕೆ, ವಿ ಆರ್ ಮೈನಸ್ ಎನ್ ವಿ. ವಿ ಐ is equal to VR only when we subtract the some volume. VI is equal to PI is equal to PR after addition of this factor. Here we observe the two different constants A and B. These two constants are known as van der Waal constant. N square is nothing but amount of gas, V is nothing but a volume. Okay, so this is about the correction factor for pressure and correction factor for correction in volume. Okay, volume, it is correction for pressure, correction for volume. After introducing or substituting the equation 1 and 2 in ideal gas equation, what we get? P R plus AN square divided by V square into, it is B, correct? 1 in ideal gas, equation 2 in ideal gas, V minus NV or VR minus NV. P is equal to, it is P, it is V. Now PV is equal to nRT. This is equation number 3. Equation number 3 is nothing but van der Waals equation for real gas. Now PV is equal to nRT. For 1 mole of a gas, can anybody guess what is the equation for 1 mole of a gas? What happened? The equation number 3. Equation number 3 become P, or you can consider P only, okay? It is also correct. P plus N become 1. What is the meaning of 1 mole? N is equal to 1. A by V square into V by B is equal to, N is equal to 1, therefore it is RT. Equation number 4. Then what are the things in this equation? P pressure, V volume of pressure of real gas. Okay, next N is amount of substance, mole of a gas. Next A and V are van der Waals constant. Okay, van der Waal constant is R is gas constant. T is temperature, absolute temperature. So these are the things are very important for your exam point of view. For 2 marks, derivation part is not required. Okay, only the equation. Please remember the equation and note it down. Equation and what are the things under this equation. For your competitive exam purpose, another thing is important. Unit of van der Waal constant. what is the unit of van der Waals constant? I am left it to you. Okay, so please work on it and give the unit for A and B. I give the hint how to derive the unit for A. For A, I am consider P plus an square divided by b square is equal to nothing, is 0. Here, what is A? A is equal to, or an square by b square is equal to p minus, you can consider it as plus p. Now, if A is equal to pv square by m square. Give the units for pressure, volume and mole, and what is the unit? Okay, what is the unit? And similarly b minus nb, b is equal to v by n. What is the unit? What is the unit of v and n? Okay, please work on it and give the units. Okay, it is left to you. Okay, this is a work for you. Consider it as a homework. Okay. Next, what is the meaning of A and B? And what are the things inside A and B? Van der Waals constant. Here, the constant A completely depending upon the value of A completely depending upon the applied pressure, correct? Pressure is applied, volume decreases. During that, the amount of volume decreases is completely depending upon the intermolecular force between the molecule. If intermolecular force is more volume decreases, we should apply a smaller value, here bigger value of B. Because of that, the A is completely depending upon the intermolecular force. If intermolecular force is stronger, A is smaller. If intermolecular force is lesser, A is bigger. So, the value of A, or better to consider the magnitude, magnitude of A, the value A is depending upon the intermolecular force, and the B is completely depending upon the volume of the gas molecule. What happened in case of ideal gas? Volume is negligible, correct? But real gas, volume is considerable. So volume of a gas molecule is considerable, therefore we give the correction factor for volume. Pressure, there is no force of attraction, but there is a force. There is no force in case of ideal, but in case of real there is a force, therefore we give the correction A. Because of the error in the measurement of real gas and ideal gas, or the deviation of real gas with ideal gas, is completely depending upon the two wrong assumption of kinetic molecular theory. For that purpose, we give the correction, or not we, van der Waals give the correction factor for that two part, intermolecular force and volume. Okay, so this is about A and B. A and B are the magnitude of force of attraction and volume of the gases. Okay, so these things are very important. Next very important thing is the last part of this topic, is liquefaction. It is the phenomena, or it is a process, or it is a phenomenon of conversion of gas into liquid is known as liquefaction. The process of conversion of gas into liquid is known as liquefaction of gases. Next, in process gas liquid ಮಾಡೋ process ಗೆ liquefaction ಅಂತ ಕರೀತಾರೆ. Okay, the liquefaction was studied by Andrew by considering carbon dioxide gas. Liquefaction is completely studied or effectively studied by Andrew It was studied by Andrew by considering the CO2 gas, carbon dioxide gas. Therefore, what we observed, the constant curve from carbon dioxide gas is known as Andrew's isotherms. ಅಲ್ಲಿ ಏನು ಸ್ಟಡಿ ಮಾಡ್ತೇವೆ ಅಲ್ಲಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಟೆಂಪರೇಚರ್ ಕರ್ವ್ಸ್ ಬರ್ತದೆ. ಕಾನ್ಸ್ಟೆಂಟ್ ಟೆಂಪರೇಚರ್ ಕರ್ವ್ಸ್ ಅಂದ್ರೆ ಏನು? ಐಸೋಥರ್ಮ್ಸ್, ಬಾಯ್ಲ್ಸ್ ಲಾ, ಕರೆಕ್ಟ್. ಐಸೋಥರ್ಮ್ಸ್, ಆ ಐಸೋಥರ್ಮಿಗೆ ಎಂಡ್ರ್ಯೂಸ್ ಐಸೋಥರ್ಮ್ಸ್ ಅಂತ ಹೇಳ್ತೇವೆ. ಐಸೋಥರ್ಮ್ಸ್ ಯಾವಾಗ ಬರ್ತದೆ? ಇನ್ ಕೇಸ್ ಆಫ್ ಪ್ರೆಷರ್ ವರ್ಸಸ್ ವಾಲ್ಯೂಮ್ ಗ್ರಾಫ್. Okay, let us discuss about Andrews isotherm. I would like to draw a graph for carbon dioxide gas. Okay, please give more concentration on this part, very important. Once you study completely, then there is no need of reading and all that. Okay, and consider a PV graph for carbon dioxide gas. It's a PV graph. Pressure versus volume, pressure along y-axis, volume along x-axis. Here, for a carbon dioxide gas at lower temperature, what happened at lower temperature? Okay, what about what type of curves we observed at lower temperature? 20 degree, consider it as a 20 degree Celsius. Temperature ಕಡಿಮೆ ಇದೆ, ನೀವು ಪ್ರೆಷರ್ ಹಾಕಿದ್ರೆ ಏನಾಗುತ್ತೆ? ಡೈರೆಕ್ಟ್ಲಿ ಲಿಕ್ವಿಡ್ ಗ್ಯಾಸ್ ಅಲ್ವಾ, ಜನರಲ್ ಆಗಿ ನೋಡಿ. ಓಕೆ, ಸೊ ಟೆಂಪ್ರೇಚರ್ ಕಡಿಮೆ ಇರೋ ಜಾಗದಲ್ಲಿ ಮಾಯಿಶ್ಚರನ್ನು ಜಾಸ್ತಿ ನೋಡ್ತೀರಿ ನೀವು ಅಲ್ವಾ. ಸೊ ಅಂದರೆ ಗ್ಯಾಸಸ್ಸು ಲಿಕ್ವಿಡ್ ಆಗಿರ್ತದೆ, ಲಿಕ್ವಿಡ್ ಸ್ಟೇಟಿಗೆ ಕನ್ವರ್ಟ್ ಆಗಿದೆ ಬಿಕಾಸ್ ಆಫ್ ದ ಅಟ್ಮಾಸ್ಫಿಯರಿಕ್ ಪ್ರೆಷರ್. ಅಟ್ಮಾಸ್ಫಿಯರಿಕ್ ಪ್ರೆಷರ್ ಇಸ್ ಇನಫ್, ಬಟ್ ಟೆಂಪ್ರೇಚರ್ ಜಾಸ್ತಿ ಇದ್ದಾಗ ಗ್ಯಾಸ್ ಲಿಕ್ವಿಡ್ ಸ್ಟೇಟಲ್ಲಿ ಇರೋದಿಲ್ಲ ಅಲ್ವಾ. ಸೊ at lower temperature, small as pressure releases, volume increases, gradual variation. Similarly, for another 25 degrees Celsius, next is 27 degrees Celsius, next, okay, next is 30 degrees Celsius, next 30.98 degrees Celsius. Please remember, here we observe the constant variation, and after that can't observe any variation. Under this curve we observe a constant variation. Okay, constant variation means it is straight line with x-axis. Now there is a sudden change. It is for 20, 25, 27, is for 30 degrees Celsius. Okay, so what it indicates? This is known as Andrews curves or constant temperature curves. Collection of constant temperature curve is called isotherms. These are known as Andrews isotherms. Once again I recall, isotherm means constant temperature curves obtained under PV graph. Okay, here there is a constant things is observed. What happened in this case? When we release the pressure, volume suddenly increases. But in some amount of pressure, there is no change in the volume. After that, This pressure, when this pressure releases, suddenly volume increases, goes to gaseous condition. Volume increases means gaseous condition. This one is liquid condition, correct? Pressure, high pressure is applied at low temperature, liquid. Liquid comes to gases. Or better to draw another. If you have any confusion in this cases, you can draw another graph. Okay, I am going through according to the your book, but you just rearrange. I am applying the pressure here x-axis. Now it becomes VT graph. V along y-axis. Okay, initially at lower temperature, pressure is less. There is no pressure. It is gas. Gas, correct. There is no pressure. ಏನು ಒತ್ತಡ ಇಲ್ಲ, ವಾಲ್ಯೂಮ್ ಜಾಸ್ತಿ ಇದೆ ಅಲ್ವಾ, ಅವಾಗ ಗ್ಯಾಸ್ ಇರೋದನ್ನು ಏನು ಮಾಡಬೇಕು ನಾವು ಈಗ ಲಿಕ್ವಿಡ್ ಮಾಡಬೇಕು. ಸೊ ಪ್ರೆಷರನ್ನು ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ವಿ ಅಪ್ಲೈ ದ ಪ್ರೆಷರ್. So after applying the pressure, it gets converted into liquid. It comes to liquid state. So this is the curves, Andrews isotherms. Here we observe the 30.98 degree for carbon dioxide gas. We observe the one phase, but in other cases, lower temperature, we observe three phases: gas, liquid, and there is no variation in the volume. Volume remains same. Volume remains same means it not converted into gas or not converted or present in a liquid state. There is a phase between gases and liquid is observed, the vapor phase. So here we observe the vapor phase, and after that we can't observe any vapor phase more than 30.98 degrees Celsius. More than 30.98 degrees Celsius for carbon dioxide gas can't be liquefied. Liquid ಆಗೋದಿಲ್ಲ, gases ಆಗಿಯೇ ಉಳ್ಕೊಳ್ತದೆ, remains as a gas. You can apply however amount of pressure. ಎಷ್ಟು ಪ್ರೆಷರ್ ಹಾಕಿ ಗ್ಯಾಸ್ ಆಗೋದಿಲ್ಲ. Reason, temperature is 30.98. More than 30.98 degree, carbon dioxide gas remains as a gas, not converted into liquid after applying however amount of a pressure. So ಅಷ್ಟು ಟೆಂಪರೇಚರ್ ಒಳಗಡೆ ಗ್ಯಾಸ್ ಮಾಲಿಕ್ಯೂಲ್ ಒಂದಕ್ಕೊಂದು ಹತ್ರ ಬರೋದಿಲ್ಲ ಅಂದರೆ ಲಿಕ್ವಿಡ್ ಆಗೋದಿಲ್ಲ. Therefore this temperature is known as TC. It is nothing but critical temperature. Critical temperature. What is the meaning of critical temperature? What is the definition? Critical temperature is nothing but temperature above which gas can't be liquefied however amount of pressure we can apply. ನಾವು ಎಷ್ಟೇ ಪ್ರೆಷರ್ ಹಾಕಿದ್ರೂ ಈ ಟೆಂಪರೇಚರ್ಗಿಂತ ಮೇಲೆ ಗ್ಯಾಸು ಲಿಕ್ವಿಡ್ ಆಗೋದಿಲ್ಲ. It is known as critical temperature. How much? Critical temperature for carbon dioxide gas is 30.98. Suppose we measure the volume at that condition. Volume at critical temperature is known as critical volume. We see critical volume. Next, pressure at critical temperature is known as critical pressure. Combinedly we call it as critical constants. Critical constant. What is the meaning of pressure? Pressure needed to convert gas into liquid at critical temperature. Volume at which or volume required or volume observed during the critical temperature is known as critical volume. So combinedly we call it as a critical constant. So these are about the liquefaction of the gases for carbon dioxide. Suppose we consider nitrogen, it is completely different because nitrogen gas is compressed around 4 degree. So this point is observed at 4 degree Celsius. Okay, for different gases we observe the different temperature, critical temperature. Meaning ಏನು, ಗ್ಯಾಸ್ ಈ ಟೆಂಪರೇಚರ್ಗಿಂತ ಮೇಲೆ ಗ್ಯಾಸ್ ಆಗಿ ಉಳ್ಕೊಳ್ತದೆ, ಲಿಕ್ವಿಡ್ ಆಗೋದಿಲ್ಲ. ಅದರ ಕೆಳಗಡೆಗೆ ಪ್ರೆಷರ್ ಅಪ್ಲೈ ಮಾಡಿ ಲಿಕ್ವಿಡ್ ಮಾಡಬಹುದು. Temperature, in another word, temperature below which gas can be liquefied. Okay, So this is the meaning of critical temperature. Okay, this completes the your states of matter or gaseous state. Liquids part was deducted, so therefore there is no need of study of liquid state. Okay, the numerical part or problem part remaining, that part will be discussed through a live classes. Okay, thank you for watching.